All right, guys, we're going to go through the homework packet for the week. This is also the study guide for our Unit 2 linear equations test. So just a little preview of how I want you to use this. I'm going to do one question from each page. If you are having trouble with that page, I want you to watch the part of the video where I'll do an example. Then I want you to pause the video, do the rest of the page, and then move on. So again, if you're having trouble, watch me do one of the problems, then do the rest of them that look like that until you're comfortable, and then move on through the packet until you're done. So here on the first page, I'm going to do problem number 1. On this page, we're being asked to write the slope-intercept form of the equation of each line. Now, slope-intercept form, those are the equations that we've been looking at so far. So I want to write an equation that looks like y equals mx plus b. Let me zoom in a little bit. All right, now there are two pieces that we need here. M, that's our slope, and then B, that's our y-intercept. Now you can really find either one first, but when looking at graphs, it's easiest to find your y-intercept. So if I look at this line, the y-intercept is where I cross the y-axis. So if we look right here, this is where our line crosses the y-axis. This is the point 0.04. So this means our y-intercept, or our b value, is positive 4. All right, so far so good. Now we just need to find our slope. So when we're looking at graphs, I need to identify 2 different points in order to find my slope. So we already have one here with our y-intercept. Now I'm going to look along my line to see where there's another easy point that I can read. So I see there's one right here. Now you can find your slope using one of 2 methods. The first one, you could use your equation y2 minus y1 over x2 minus x1. This is completely fine. But when I'm looking at a line like this, I think it's easier just to look at the movement. So to get from this point to this point, I'm going to go down 3 units, go down 1, 2, 3. I'm going to go right 1, 2, right 2 units. Now just to double check, the reason that this is in the numerator is that when I go down, that's my change in y. And then when we go left or right, that's our change in x. Now before we take this and write our slope, I just want to look at the line. And I noticed that when we're moving from left to right, my line is going down. So right away, that tells me that our slope is going to be negative. This should be one of your first steps, or if you are struggling, I need to see this on every single problem you do, especially on your test. So we know that our slope is going to be negative. Now down 3 tells me that our change in y is negative 3. And then our right 2 tells me that our change in x is positive 2. Negative 3 over 2 simplifies to just negative 3 over 2. So our m value, or our slope, negative 3 over 2. Now I can write my equation right down here. If we look at our equation as y equals mx plus b, I can rewrite this as y equals negative 3 over 2x plus 4. Great, so right now I want you to stop, do the rest of the problems on this page, and then move on to the next page in your packet. All right, so on page 2, I'm going to do number 1 here. This one's a little bit easier than the first page because we're just looking at the slope, and there's just one little nuance. So I want to find the slope of the line and represent it using 3 different equivalent fractions. So they've already identified the 2 points for us. So my slope, my m, I'm going to use the same process we did on the last one. To get from here to here, I'm going to go down 1 and then right 3. So my slope, again, this line is going to be have a negative slope because it's going down. So it is negative 1 over 3, or negative 1/3. Now I want to find 2 other equivalent fractions. So I need to find fractions that simplify to negative 1/3. To do that, I'm just going to take our slope negative 1/3 and multiply it by any fraction that has the same number in the numerator and the denominator, for example 2/2. The reason I can do this is because 2/2 is the same as multiplying by 1, and that doesn't change the value of this at all. So when we multiply by 2/2, we get negative 2/6. So this is our second fraction to represent this slope. And then one more, if we take negative 1/3 and multiply it by 3/3, we would get negative 3/9. You'll notice each of these would simplify to negative 1/3. They each also describe the slope of this line. So if I were, for example, to start at this point, and this slope would mean I would go down 2 and right 6. If I started here and went down 2 and right 1, 2, 3, 4, 5, 6, I would end up at this point. So that just describes the slope of this line from 2 different points. All right, so you just have one more example here, so I want you to pause the video, try number 2 using this same method. All right, moving down to the bottom half of the page here. We're going to be graphing equations, but first we need to make sure that we're able to fill out a table. So at this point, this really tells me that you have a pretty thorough understanding of how equations work in relation to their tables and also their graphs. So we're given the equation y equals x plus 4, and then in this first column we're given a set of x values. You would be able to choose your own. In this case, they're given to us. This is going to be our work column where we're going to show all our work. Then this is going to be the y value we get out, and then to put it all together, we're going to write our coordinates in this last column. All right, so if my x value is negative 2, that means wherever I see an x, I'm going to substitute negative 2. So this would look like negative 2 plus 4. Negative 2 plus 4 gives me a positive 2. So I would take this point and this point, and my coordinate would be negative 2, positive 2. My x value was negative 2. The y value I got out was positive 2, so I get negative 2, positive 2. So if we kept doing this the rest of the way down, if x equals negative 1, our equation is negative 1 plus 4, which would give us a positive 3. If x equals 0, we have 0 plus 4, or positive 4. And then the last one, if x equals positive 1, our equation is 1 plus 4, giving us a positive 5. So the corresponding coordinate points here are negative 1, positive 3, 0, positive 4, and then 1, positive 5. Great, so we took the equation here, used our table to find some coordinate points, and now we're just going to graph them. So if we have the first one, negative 2, positive 2, negative 1, positive 3, 0, positive 4, and 1, positive 5. Now remember, all these equations will go forever and ever this way and this way. So to draw my line, I'm just going to draw a straight line through our points, make sure that we have our arrowheads on both ends. And now last piece, to check our work, because we have a pretty good understanding of our equations, I know that if we look at this equation, this value right here, our b value, is our y-intercept. So I want to go back down to my graph and check at the y-axis, does it cross at positive 4? So if we go to our y-axis and we go up 1, 2, 3, 4, see we have our point 0, 4. So that means yes, we have the right y-intercept. Now to check our slope. Now this one's a little tricky because I don't have a number here, but remember, if there is not a number in front of our x, we assume that our coefficient is positive 1. Positive 1 is the same as 1 over 1, meaning we would go up 1, right 1. So if we were to look back down at our graph, to get from this point to this point to this point to this point, we go up 1, right 1, up 1, right 1, up 1, right 1. So this tells me we're able to check that our equation, our table, and our graph are all representing the same thing. So I want you to take this idea, try it again here. Here's your equation, fill out your table, and then graph your line. All right, so we didn't directly do this this week, but this is a concept that we've kind of used throughout the unit, and we're being asked here, determine whether the given point 2, 5 is a solution to the equation y equals 3x minus 1. So the biggest piece here is we need to have an understanding of what it means for something to be a solution. So if something is a solution, that means that the xy will make the equation true. So if I take this x value, 2, and this y value, 5, and I plug them in or substitute them into our equation, I should get the same thing on the left side and the right side. Now to check this, I always rewrite the equation. So if I rewrote this over here, y equals 3x minus 1. Now our coordinate point, 2, 5. Anywhere that I see a y, I'm going to put the value 5. So this would be 5 equals 3 times our x value, which is 2, minus 1. So now we can just evaluate the right side. We would get 5 on the left equals 3 times 2 gives me 6, minus 1. 6 minus 1 equals 5. So on the left side and the right side, we have a value of positive 5. So that is a check. So we can say yes, 2, 5 is a solution. This is going to be really useful for when we're writing equations. Picking a point, plug it into your equation to make sure it is a solution. But just for these three, all you need to do is use your coordinate points, plug them into your equation, and see if you get the same thing on the left and the right side. All right, we just have 2 more sections. This one we have 1, 2, 3, 4, 5, 6 different graphs. And I'm asking you to sketch the graphs, and you'll notice right away these equations look a little bit different. So they don't look like they're in y equals mx plus b. Our first one is y equals 3. Our second one is x equals negative 4. So right away something is a little bit different here. So let's take a look at number 15, the equation y equals 3. Now if you remember from the beginning of the year, this represents the line where all y values are positive 3. So if right away you're not really sure what that looks like, the best strategy to do is just think of a couple coordinate points where our y value would be positive 3. So that means there's a 3 here, there's a 3 here. Now, because all of the y values are positive 3, that means that no matter what I pick for x, the y is still going to be positive 3. So let's say we pick the x value 1, the x value 4. We can even do one more. We can get a negative. We can do negative 2 for my x, but most importantly, our y has to be 3. And then let's just plot these points and see what we get. So the first point, 1, 1, 2, 3, 1, 3 would be right there. 4, 3 would be 1, 2, 3, 4, 1, 2, 3, right there. Negative 2, 3 would be negative 2, positive 1, 2, and 3. So right away we're starting to see it looks like we're kind of getting a straight line across here, which is exactly what we wanted. So this is what our line looks like. You'll notice that no matter where I put my pencil across this line, the y value is positive 3. I never move up or down at all. The x values will change, but the y is always equal to positive 3. This is the line y equals positive 3. So I want you to do these last 5. Make sure that you determine whether it is your x value or your y value that is fixed. Make some coordinate points with that given value, and then draw your line. All right, so this is the section that we've been having the most trouble with, just because it's brand new. I was definitely anticipating this being tricky, so let's make sure we pick a good one here. I'm going to do number 3 because I think it'll really get at all the possible misconceptions we might have on the test. So we're being asked again to write the slope-intercept form equation, y equals mx plus b, of the line that are going through the given points. So if we look at number 3, I want to write the equation for the line that goes through the points -4, 0, and +1, +5. So again, I'm going to rewrite my equation y equals mx plus b. So I need to find a slope, and I need to find my y-intercept. So I'm not really sure what my y-intercept here, and I'm also not really sure what my slope is, especially because there's this negative value here. Now, every time you do one of these, I want you to sketch just what your graph might look like. So if you are at the point -4, 0, that would be right there, -4, 0. And then the coordinate point 1, 5 would be over here. Now, this just gives us an idea of what our line is going to look like. So this tells me, okay, my slope is positive, and my y-intercept, I'm not 100% sure, but it looks like it's going to be about 4. So this is the estimation that's going to help you check your work. This is something that, if I see, will result in bonus points on the test, and maybe, I don't know, we'll figure something else out too. But I want to see this on everybody's test this week. Now, so back to these points. I don't know what my y-intercept is, but I know that I can calculate the slope. So if I were to write the points again, -4, 0, going to 1, +5, I'm going to find the slope using the change in y over the change in x. So my change in y, 5 minus 0 equals 5. And then my change in x, 1 minus -4. Subtracting a negative is the same as adding a positive. So this is the same as 1 plus 4 or +5. This is the change in x. This is the change in y. Now, notice how I did the subtraction problem on both sides before determining the change in x and the change in y. This has been the most common mistake of people trying to jump right from here to their final number. Especially here when we have negative numbers, I need to see the subtraction problem. I promise this will catch 90% of the subtraction mistakes. So back to the problem. Our change in y is 5, our change in x is 5, so change in y over change in x. 5 over 5 is the same as 1. Change in y over change in x is our rate of change, or our slope. So this is our value for m. So we have our slope, but now we need to find the y-intercept. So we're just going to work backwards from one of the points that we already know. If we have the point 1, 5, and I need to find the y-intercept. The y-intercept always has an x value of 0. So now I need to figure out how to work backwards. So this tells me that the m value tells me that every time x goes up by 1, y goes up by 1. But in this case, we're going backwards. So I need to think, if x is going down by 1, what's going to happen to y? Now in this case, it's kind of easy to think like, okay, if x is going up by 1 and y goes up by 1, then when x goes down by 1, y goes down by 1. But if these numbers were a little more complicated, what you need to do is multiply -1, your change in x, this is the change in x, times 1, our m value. You're multiplying your change in x by your slope to get your change in y, which is -1. So if we started at 5, our change in y is -1. Working backwards would leave me at +4. The point 0, +4 is the y-intercept. So this means b equals +4. Now I can use this and this to write the equation. Y equals 1x plus 4. Now the very last piece here is I want us to always be checking our work with these problems. So if I have the equation y equals 1x plus 4, but I notice that in the problem they told us that the point -4, 0 was on the line, that means I need to be able to plug x as -4 and y as 0 into this equation and get the same thing on both sides. If you can do this and plug it into the equation and get the same on both sides, that means your equation is perfect. If not, that means you made a mistake somewhere up here. You got to go back and check. So let's substitute these in. If y equals 0, we get 0 equals 1 times -4 plus 4. 0 equals -4 plus 4. -4 plus 4 is 0, so 0 equals 0. So check. This tells us that our equation is perfect. So the equation for this line, y equals x plus 4. Now this one's a little bit trickier, so let's go back and just go through our steps one last time. First thing we did, given these points, is we calculated the slope. The change in y, 5 minus 0, was +5. The change in x, 1 minus -4, was also +5. When we made our ratio to find the slope, 5 over 5 is 1. This is the m value. Now we took one of the points we already knew, 1, +5, and we worked backwards to get to the x value 0, where our y-intercept is. Our x was changing by -1, so we multiplied that change in x, -1, times our slope, or our rate of change, +1, and that gave us our change in y. So if our change in y was -1, and we started at 5, 5 minus 1 gave us 4. Now this point 0, 4 is our y-intercept, so that means our b value is +4. And I can write our equation as y equals 1x plus 4. Then we just use this last coordinate point to check our work, and we were all set. So I want you to go back through 1, 2, and 4. Make sure that you can do this 100% perfectly. This is going to make up a good portion of this unit, as well as getting into systems of equations. So make sure that we got a good understanding here. All right, this is the last piece of this unit and the last piece of this packet and our test. So we need to determine the number of solutions to the following equations. Now, determine the number of solutions. That means I can either have one solution, I can have no solutions, or our last option, we can have infinitely many solutions or infinite solutions. Now, just to help organize our thinking, one solutions are the ones that we are used to. That's where we get x equal to some number. For example, x equals 3. When we have no solutions, that's where we get some number, maybe a, equal to some different number b. We saw some examples like this in our packet where we got -2 equals +7. This obviously is not true. This means it has no solution. And then infinite solutions, meaning we solve and we get some number a equal to itself. An example there would be solving to get 4 equals 4. This is a true statement no matter what x is. So this has infinitely many solutions. So just to make sure that we all know every part of solving these equations, we're going to do number 9 together. So on the left side, we have 3 plus 5n, and on the right, 5 times, in parentheses, n plus 2 minus 7. Now, seeing the parentheses with this number outside tells me right away there's going to be some distribution, and then having a -7, or subtracting 7 on the outside, tells me I'm probably going to have to combine some like terms. So on the left side, nothing changes, so I'm just going to rewrite 3 plus 5n Now on the right, I'm going to distribute my 5. Make sure you distribute to every term inside the parentheses. So 5 times n is 5n. And then make sure we remember to distribute to this positive 1. The sign matters. 5 times positive 2 equals positive 10. And then we still have this minus 7. Now we're getting closer, but I see on the right side here we can still combine some of our like terms. This is the only term with a variable, so nothing else is going to combine there, but I see we have a positive 10 and we are subtracting 7. So on this right side we would still have our 5n, and then 10 minus 7 would give us positive 3 or plus 3. On the left side we still have 3 plus 5n. Now right here you might notice I have a 3 and I have a 5n on both sides. So in your head at this point I want you thinking, okay, we have the same thing on both sides. It's probably going to be infinite solutions, but let's use our inverse operations to make sure. Now if I wanted to eliminate the variable here, I would need to subtract 5n from both sides. When we subtracted 5n from both sides, make sure that we do that on both sides of the equal sign. It would eliminate this 5n, so we're left with 3 equals 3. And then if we look back up at the top, this is our form for infinite solutions, because this is always true no matter what. So we could pick any value for n, this will always be true. So that means we have infinite solutions. Great, so for the last 1, 2, 3, 4, 5 equations, I want you to use your distributive property, combine like terms, then your inverse operations to solve, and then use this guide at the top to help you determine how many solutions your equations have. Now, if you're able to do this packet, you should definitely walk into the test with confidence. This is really everything we've covered so far. If you have any questions, go back, rewatch the video, and best of luck.